Hello everyone, welcome to all in this lecture. So in the previous lecture, we have seen that I have solved or discussed 10 GATE previous year questions. So with the continuation of previous lecture, I will solve 7 numerical problems in this lecture. And in coming lecture also I will discuss. So I will try to cover each and every GATE previous year questions from the soil mechanics. If once I will finish in the soil mechanics, then I will go for the next subject also. So let's start. So the first question we have, and the first question is statement link answer question. So whatever the answer will come in the 11 questions, though that will use in the 12. So both 11 and 12 are linked with each other. Okay. जो पहला क्वेश्चन हमारा है, the unconfined compressive strength of saturated clay sample is 50 kilopascal. So पहले हम ये समझते हैं कि what is unconfined. So if we'll see in the triaxial test, there is a formula. So I will derive one sigma 1, sigma 3, 10, pi square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2. So there is a say unconfined when there is a no confining pressure. So sigma 3 is 0. So by putting the sigma 3 is equal to 0, sigma 1 will come 2c plus 10 45 degree plus 5 by 2. And for the clay means phi is equal to 0. So by putting the phi is equal to 0, what we will get? We will get 2c 10, this is into, right? 2c 10, 45. So we know that 45, 10, 45 degree is 1. So we get 2c. And sigma 1 is equal to, in unconfined stress, sigma 1 is basically, we'll see, sigma 1 is equal to sigma d plus sigma 3, or sigma d is the deviated stress. Once sigma 3 is 0, you will see sigma 1 is equal to sigma d, and that sigma d is equal to qu. Whatever pressure we are applying, that is unconfined compressive stress. So finally, you can get the equation C is equal to qu divided by 2. C is equal to qu divided by 2. Now we got how it came. So Cu we have, what is the value of Cu? Qu we have 54 kilopascal divided by 2. So we get 27 kilopascal. That is C. That is C. You can see from the relation, coefficient property of clay is half of the unconfined compressive strength, right? So first we have this formula. By putting the value of C, sigma 3 is equal to, that is cell pressure, that is confining pressure is equal to 0, we get this equation. And flow for clay, after putting the value of H equal to 0, we get this relation. Sigma 1 is equal to 2C. Basically, sigma 1 is sigma D plus sigma 3. Sigma 3 is confining, sigma D is deviated stress, whatever the pressure we are applying through the jack. So sigma 1 is equal to sigma D. So the pressure we got in unconfined compression, that is QU. So there is a relation C is equal to Q by 2. So after putting the value of 54 by 2, we got the 27 kilopascal. That is C. Right? So now we are clear about. So C is coming 54 divided by 2, that is 27. So option B, correct option is C. So 12 question. I already said that that question 11 and 12 are linked with each other. So whatever the data we got in the 11, so just first note down that data we will use in the 12. C we got 27 kilopascal, right? Okay, so let's what is the question number 12? If a square footing, see footing, shape of footing is maintenance square of size 4 into 4 meter into 4 meter. It's resting on the surface. Again, there is a second data we have surface deposited over the clay. So ultimate bearing capacity footing as per Terzaghi equation. So see, for the square, what is Terzaghi for the square? So for square 1.3 C NC plus gamma DF NQ plus 0.5 gamma B N gamma, right? So this is the general expression for a square footing. Sorry, this is 4.4. This is 0.4, right? Okay, so this is general expression for ultimate bearing capacity for the square footing. See, in this case question, it's saying surface, footing resting on the surface. It means df is equal to 0. Are you getting my point? So this expression will be 0. And here it mentioned clay. Clay, it means phi is equal to 0. Phi is equal to 0, it means what we have? We have NC is equal to 5.7. We have NQ equal to 1, and we have N gamma is equal to 0. So N gamma is equal to 0, so this expression will be also 0. So finally we have QU for a square footing 1.3 into C. What is C? We have C calculated, ultimate bearing unconfined compression test, that is 27 into what is NC? 5.7. You can calculate, so it will get, you can get around 200. So you can apply, you can do the calculation. I have calculated already, so I'm just using this relation. So you can see now. So 200, let's try. We'll get this, we'll get this relation. Okay. Okay, so you can see what option we have. So it's option C is correct, right? Let's go for the next questions. Now this question number 13 and 14 both are linked answer questions. Means whatever the data we will get in the question number 13, that will be used in the question number 14 also. So now you can read the questions. A column is supported on a footing as shown in the figure. The water table is at 10 meters below the base of the footing. See, so depth of foundation we have 1 meter, we have width 1.5, we have length 3 meter, right? Gamma we have NQ, in gamma or NC, here you can see there is a sand. There is a sand. Means C is equal to 0, so NC we don't require the NC. Okay, so here the sand, C is equal to 0. So column. So we have to calculate net ultimate bearing capacity of the footing based on Terzaghi bearing capacity equation, right? Okay, so what we know, we will see the water reduction factor. So we have discussed water reduction factor 0.5 plus 0.5 into B divided by B, right? It should be less than or equal to 1. So once water table is supposed here, and this is the B distance, right? So B in this case is greater than E. Once this is the condition, then gamma W is 1. Means there is no need to correct. There is no need to correction. There is no effect of water table, right? There is no effect of water table. Means no need to take gamma, saturated gamma, submerged. Everywhere you will see there is a gamma, bulk density of soil. So in this case, you can see the B is equal to 10 meter and capital B is 1.5. Sorry, 3 meter, right? So you will see this is greater than B. Means there is no water reduction factor will be 1. It means there is no need to correction, right? Okay. So now we can write the ultimate bearing capacity for the footing, and this is the, what is this? This is the rectangular footing. So we have the formula for rectangular footing. What is the formula? 1 plus 0.3 B divided by L into C and C plus gamma TF NQ plus 1.1 minus 0.2 into B divided by L into half B gamma N gamma. In the last there is a N gamma, right? We can write also. Okay, so we can write N gamma, right? So now we have the C is equal to 0. So after putting the value of C is equal to 0, this expression will be 0. Okay, and depth of foundation, so rest we can calculate. So gamma we have, what is the 18 into depth of foundation we have 1 and NQ we have 24 plus into 1 minus 0.2 into B we have 1.5, L we have 3 into half into what is gamma 18 into what is B 1.5 into N gamma, that is 20. So we get some value, right? So we have in the question you can say there is a you have to need to correct net ultimate calculate net ultimate bearing capacity. So chalo net निकालते हैं. Net मतलब QNE by notation you can see QNU. So QNE क्या होता है? Gross minus overburden pressure. So gross यहाँ से निकलेगा और आप डायरेक्ट भी निकालना चाहते हो तो क्या आ जाएगा? गामा TF NQ minus 1 plus 1 minus 0.2 B divided by L into half gamma B and gamma. So by calculating this value, gamma we will take bulk, whatever given in the question, that is 18 kilonewton per meter cube. So we have seen that when the B is small b is greater than capital B, so there is no need, there is no effect due to the water. There is no effect on the soil. So you will get 657 kilonewton per meter square. You can solve also. We have solved this. We have already calculated. So I'm writing this result. So 657, and that is net ultimate bearing capacity. So you can check the option. Option C is correct. मैं आपको हमेशा से बोलता हूँ, you have to note down and calculate what are the data given. Sometimes you will see data are given in the direct format, like whatever the C, Q5, whatever. But sometimes you will see data is given in the words. So you have to find what is the meaning of that. Means when you are saying the question is saying the resting on the foundation means foundation is resting on the soil, sand, clay means DF is equal to 0. Sand, clay, it means Y is equal to 0, C2, whatever. So you have to see that also. And then we have to just see what we have to calculate, and try to be relate the both the things. Why try to be recall some relation? Try to some relation that relation will reach you up to the destination from the given, whatever the data given to the what we have to calculate. So always try to think like that. So now we can go for the next questions. So here we can what data we get NQ, net ultimate bearing capacity. So let's move forward. So next question we have. So whatever the data given in the previous question, that is first slow down. So in the previous question we got NQ 557 QNU kilonewton per meter square, right? So now we can go for this question. Safe load that the footing can carry with a factor of safety 3. So to calculate the safe load, first calculate what is the safe load pressure, what is the safe bearing pressure, so that we can calculate Q is NS, right? Net shape. So that is basically Q and U divided by factor of. I get my point? This is the pressure. This is not a load. This is the pressure. This is also in the pressure format. So we can calculate 657 divided by what is factor of safety? 3. What is factor of safety? 3. So this is the pressure. Okay. So in the question, I asking about the load. So safe load. What will a safe load? So the pressure is developed on which area. So that area we will calculate, we will multiply by this net safe pressure. So we can get the safe load. So we can multiply QNS into area. So QNS 657 divided by 3 into what is the area? What is the area? So area is not given here, right? So in the previous question, you can see area was given. Yeah, 1.5 into dimension is given. Okay, so what is the dimension? You can see there is a rectangular footing, so that dimension is 1.5 into 3. So this is the area, right? Rectangular area. So after solving this, I have already calculated, so I'm writing this result. But you don't write this, you have to just solve in the calculator. So we'll get the same result. So that we get 985.5. If you will not get the same result, so bet kilonewton. So just leave some comment in the comment box. So the option we have, again, there is a C option, right? Okay. So next question we have, you can see a footing 2 meter into 1 meter exert a pressure, a footing 2 meter into 1 meter exert a uniform pressure 150 kilonewton per mm square. Not per mm square, it should be meter square. I think. Okay, leave it, you can correct it. Okay. This will be the meter square on the soil. So assuming the load dispersion 2 vertical and 1 horizontal. So in the question you can see mention what are the footing area. So see, suppose this is the foundation. Suppose this is the 2 meter into 1 meter. So this dimension, suppose this is the 2 meter. Okay, you can make other side figure also. Because this is the rectangular, so this is 1 meter. Are you getting my point? This is 2 meter, 1 meter. So this is the cross section of 2 meter into 1 meter. So I made first in the one direction and second in the other direction. I made this plan figure. You can say the sectional view also. See, the pressure is given at the base of the footing is 150 kilonewton per meter square. Right? In the question, you can correct per meter square. Dispersion is given. What is the meaning of dispersion? When the load are coming, it will not, a stress will not go burning. It will disperse outside, and there is a bit of slope. So that you can see. Suppose this is the slope. Right. Okay. So what is the slope? Slope you can see what is given 2 vertical, then 1 horizontal. Similarly, you can make this also. This is the dispersion. Okay. So there is a 2 vertical, 1 horizontal. See, at what depth the question is mentioned, you have to calculate the pressure at what depth. At what depth we have to calculate the pressure. So at given in the 1 meter. So see, this will be the 1 meter. So what will be this value? This will be the 0.5, and this will be the also 0.5. So what will be this value? This is the 2 meter. So you can see at one side there is a width got increased, 2 meter plus 0.5 plus 0.5 got 3 meter. In this case also you can see vertical distance is 1 meter, so horizontal would be 0.5, 0.5, and center to center the width is given in this direction 1 meter. So 3 meter into 1 meter. So you can see that in the previous, at the base of the footing, you can see there is a cross section of 2 into 1 meter, 2 meter into 1 meter. But at 1 meter below the base of the footing, you will get the dimension 3 meter into 1 meter. Means the pressure is acting, total load is acting on this area. Okay. So now we can calculate what are the loads. So what are the loads coming on the footing? So we can say the column load, right? So we can calculate column load. So this is the pressure, 1 kilonewton per meter square into area. So in the top, what was the area? That's on the soil inspection, 2 meter into 1 meter. So we got 300 kilonewton. This is the load, and same load is acting at the base of the area where the area was 3 meter into 2 meter, not 1 meter, 2 meter, right? 0.5, 0.3 into meter, 2 meter. So we can calculate. So we can calculate the pressure at 1 meter below the footing. So we have seen that 1 meter below the footing, so there is a load. And what is the area? So area is in the top, at the base of the footing, there is an area 2 meter into 1 meter. At the 1 meter below, there is a, due to dispersion, we got the area 3 meter into 2 meter. So by solving, we can get 50 kilonewton per meter square. You can see there is a 1 meter, so dispersion you got 2 meter, and there was a 2 meter, by dispersion it got 3 meters, so 3 into 2. So you can check the option A is correct. Let's go for the next questions. See, you can read the question. The bearing capacity of a rectangular footing of a plant dimension 1.5 meter into 3 meter resting on the surface on a sand deposit, what estimated 600 kilonewton per meter square, right? When the water table far below the base of the footing, it is written far below, it means P is greater than B, or we can say B is greater than B also. Means there is no effect of water. No effect of water. Or we can say water reduction factor in the third term, that is 1. Okay. So the bearing capacity in the kilonewton per meter square when the water table rises, depth of 3 meter, 1.5 meter, and Q 0.5 meter. Okay. So let's first just note down what are the data given. So you can see in the question it is mentioned resting on the surface, it means df is equal to 0. The other is for they say sand deposit, it means C is equal to 0. So now we can calculate the ultimate bearing capacity for rectangle. So I'm writing there is a okay. I'm writing in the first expression there is a C. So by putting the C is equal to 0, the first expression will be 0. You get your point. In the second expression, gamma df NQ. So in the second expression, there is a multiplication with df. So after putting the value is equal to 0, the second expression will be 0. So what is the third expression for the rectangular footing? Right? So we can write for the rectangular footing 1 minus 0.2 into B divided by L into half comma B n gamma. Okay, and this value is given. So this for the condition, this value is given for 600 kilonewton per meter square. Right? So you can put the value. So B is 2. This will be point. For putting the value of B and L, you will see there is a point. So 1.5 divided by 3. So 2 and 2. This will be the, we'll see 0.45 comma B n gamma. Just note out this is the equation first. So let's check the option. For the bearing capacity, what is the B? B we have 1.5 meter. So this B, this is the B. So in case when the uh, water table is rises to the depth 3 meter below the wall. So it's in the first case when it's saying 3 meters. So in this case, this is the case where B is equal to greater than B, because B is 3 meter and capital B is 1.5 meters. So we'll say there is no change in the bearing capacity. There is no effect of water. So 600, the bearing capacity will be the 600 because there is no effect. So for this case, there is a bearing capacity 600. Now check the second case. In the second case, you can see there is a B equal to capital B, because small b 1.5 meter and capital B is also 1.5 meter. So in this case also you will see the water reduction factor is 1. It means there is no effect on the bearing capacity of soil. So in the second case also you will see there is a 600 because there is no effect. Now check the third option. Third option where the B is equal to 0.5 and capital B is equal to 1.5. Now calculate the water reduction factor, that is 0.5 plus 0.5 B divided by capital B. Right? So now we can, let me read something. Okay. So we will get 0.5 plus 0.5 into B 0.5 divided by this 1.5 capital B. So we'll get 0.67. So now water reduction factor in the third term that we have, so we can get the bearing capacity when the B is equal to 0.5, we get the bearing capacity 0.67 into 600. This is the water reduction factor. So that we can calculate. It will almost come around 400. It will always come around. It will come around 400. So you can see for this case, we got 600. This case we got 600. For this case we go around 400. So option A is the correct. This is the correct answer. Or in the other way we can say, by calculating the water factor, in this case water reduction factor is 1. In this case water reduction factor is 1. In this case water reduction factor is 0.7. So 1 means 1 multiplying with someone, same, it will be same. So in this case, both are the 600, but in this case, we'll see 600, 0.67. Right? Are you getting my point? Okay. So next question we have, you can see. If 4 meter wide a 4 meter wide strip footing is founded at a depth of 1.5. So this is the depth of foundation, and this is, you can say, small b. Below the ground surface, C5 soil is given. The water table at a depth 5 meters below the surface. The soil properties C dash 35, 528.6 degree, gamma saturated 19, bulk 17, gamma WE. The value of bearing capacity factor, it means NC, NQ, N gamma, are given in this table. Okay, so using the Terzaghi bearing capacity equation, a factor of safety 2.5. So the net safe bearing capacity for the local shear, of the soil. So already we have the idea what is the local shear and what is the general shear failure. Okay, so you can check that in the this question I have solved in the regular class also, but there wrongly I have written this 25, but it is 35, right? Okay, so now you can correct. So for you can see what is the difference between local shear and general shear. General, whatever the explanation I was writing, that was for the general shear failure. But now here the condition is changed, local shear failure. So we have to calculate what are the mobilization angle of friction. What are the mobilization of angle of friction? So we have to calculate phi m. So what is the phi m? So that is 10 inverse 2 by 3 tan phi. So phi dash is given, that is 28.3. Right, you can see this is given. So by putting the value of 28.063, we will get that phi m is equal to 20 degree approx. We'll get to 19.97, but I'm writing 20 degree. So for the 20 degree phi m, we have the ends. You can see, check this table. For 20 degree phi, we have NC 17.7, NQ 7.4, and N gamma 5.0, right? So we have this bearing capacity factor NC, NQ, N gamma at 20 degree. So now we can go for the, and we know that C dash CM it's become 2 by 3 CS. So by take care of this all those things, CM and phi, we have calculated 20 degree. So we can write the formula ultimate bearing capacity for the local shear. This become this. You can see 2.2 by 3 by C dash and C. So this is the Q, not Q. This is the QU dash. Means bearing capacity. This is for local shear failure. This is not for general shear failure. And this NC, NQ, N gamma, we have written dash, right? It means this equation, these are these factors for the local shear failure. Means we are not seeing this value at a phi m. We are seeing this value. We are checking this value for phi m, not phi m, right? So now we have all these data. So directly we can write. So we can write also NQ. We have to calculate net bearing capacity. So let's calculate net ultimate bearing capacity for local shear. So we can write 2 by 3 C and C plus gamma df. We'll deduct the overburden pressure, so this will come NQ dash minus 1 plus 0.5 gamma B N gamma dash. Right? So now we can put the value. So what value will come? So let's put the value in the equation. 2 by 3 and to see what is C, 35. What is NC dash? That is 17.7 plus gamma. What is gamma? Gamma is given or not? Gamma, there is given saturated and there is given bulk, right? So what you will use? There is no effect of water in this case. So this gamma will be bulk. So bulk will be given 17 into gamma dA, that is 1.5 NQ dash minus 1. NQ dash we have 7.4 minus 1 plus what was given 0.5 into gamma, saturated or gamma bulk. Here with the gamma bulk, there is no effect of water. So bulk that is 17 into D, that is 4 into N gamma dash given 5. So check once again, gamma df, all this value. So by calculating, you can get some value like 4746 kilonewton per meter square. Kilonewton per meter square, 746 around. So I have calculated all these value. So I'm writing directly. But before writing this, we just calculate what the value we are getting. So now we have to calculate. We'll see. Now we have to calculate what? Net say bearing capacity. QNS. So that is QNU divided by factor of safety. Factor of safety. So by using factor of safety 2.5, 746 divided by 2.5, you will get 298.48 kilonewton per meter square. Right? So here the two things you have to remember. Water will change. So there is a two change will occur in the local shear failure. C becomes Cm, that is 2 divided by 3, and phi becomes phi m, that is 10 inverse 2 by 3, 10 phi. So these two things we have to be remembered, and this expression become this for the ultimate bed capacity for the local shear failure. So thank you. Always remember, just note down what are the data given. Sometimes data are given directly, sometimes given in the words. So you have to find out what are the data given. Means whatever the information are given in the questions that you have to find out. And then you just note down what we have to calculate. And always try to use some relation. That relation will reach you from given to what we have to calculate. Are you getting my point? So in the next lecture, I will discuss some more gate problems. So thank you. And if you are preparing for gate examination, if you want to get a good rank, so this lecture for you.